Assalamu alaikum warahmatullahi wabarakatuh. In the last lecture, we discussed about the minors. We discussed about the minor, uh, determinant, etc. Minor and determinant. Okay. So we will continue our discussion on this. So you know that suppose you have a matrix. Let's say you have a matrix A which is equal to 2, 3, 5 and 6. Then the determinant of A can be calculated like this. It is usually denoted as determinant of 2, 3, 5 and 6. Then I told you how to calculate this. So you can multiply this 2 into 6. Sorry, this is not represented like this. Okay, so 2 into 3, 2 into, sorry, not 2 into 3, it's 2 into 6 minus 5 into 3. So this is how you can calculate the determinant of a 2 by 2 matrix. So this is a 2 by 2 matrix. Now how to calculate the minor of this 2 by 2 matrix? The minor, for example, the minor matrix can be written as, actually it is having the M11, okay, M12, M21 and M22. Okay, so this is the minor basically. So you can represent it as a matrix, for example. So it is usually represented like this. This is the minor. So the M11 can be written as, suppose if you are going to calculate M11, you know that the matrix A is represented as A11, A12, A21 and A22. So, and you are talking about the position 1, 1, right? So this is the element at 1, 1. So you can ignore this row and column, and I told you it will be A22. Okay, so in this case it will be 6. So similarly, in the last class we have discussed that we can represent the minor M12 as, so the element is actually 3. So we can avoid this row and we can avoid this column. So the remaining element, it is 5. Okay, and M21, which is equal to 3 in the same way, because you can avoid this row and you can avoid this column. So the element is 3, and M22 is equal to the minor, which is regarding the 6 we are talking about, so it is nothing but 2, right? So this is what the minor, so the minor matrix can be written accordingly. So what I'm going to tell is that for the matrix A, which is represented as 2, 3 and 5 and 6, which is a 2 by 2 matrix, it's easy to calculate the minor. So it's very easy to calculate the minor matrix. The minor matrix, you can calculate the minor matrix as M11, M12, M21 and M22 in this way, that is, which is equal to M11 will be 6, okay, and regarding M12, the element 3, you will be removing that row and column, so what is remaining, it is 5. So for M21 it will be 3, and for 6 it will be 2, right? So this is what the minor matrix. Okay, so this is the minor matrix. Now we see what is the determinant of this. Determinant, we have already seen. Determinant of A is represented like this. So 2, 3, 5 and 6, and it will be 2 into 6 minus 5 into 3. Okay, so 2 into 6 is 12 minus 5 into 3 is 15. Okay, so it is minus 3. That is the determinant of this matrix. Okay, I hope this is clear to you. Now you see here there is one more thing which is known as cofactor. Okay, so for the position we will be assigning a sign. So cofactor Cij is given as cofactor Cij, that is the elements in the matrix cofactor is given as -1 whole power I plus j into the minor. Okay, so this is the minor at the position, so not m11, it is ij, sorry, it's ij. Okay, mij, so it is the minor at ij. Okay, at ij position, and this is giving a sign convention. Suppose for example I equal to 0 and j equal to 1, that means the sign will be 0 plus 1 whole power you see here it is for example sorry, it's if I equal to 1 and j equal to 1, so it will be 1 plus 1 which is equal to 2. That means the I plus j is nothing but it's equal to 2, you see, then it will be -1 whole power 2 which is nothing but +1. So the sign will not be changing. So that I will discuss. You see here the matrix A is having the elements 2, 3, then 5 and 6, 5 and 6. Then you know that the minor can be written as minor matrix can be written as for the element 2 you can write like this. For element 2, if we are talking about the element 2, then it is nothing but the 6 is the minor. Now for the element 3, the minor is 5. Okay, and for the element 5, the minor is 3. Okay, and for the element 6, the minor is 2, because you are removing that column and row. Now you can assign the sign like this. The first element you can assign plus sign, the second element in the minor matrix. So the sign matrix can be given. What do you mean by the sign matrix? It is according to this convention. Okay, so plus minus. If this is plus, this will be minus. If this is minus, this will be plus, like this. They're just changing, that's toggling. So you can see here it is plus minus plus minus. If it is a 3 by 3 matrix, for 3 by 3 matrix, the sign convention you can do like this. It will be plus minus plus, then this is plus, so minus plus, this is minus, though plus minus, so this is plus, so this is minus plus, like this. So it is changed. That it is nothing but this kind sign convention is giving you the idea that it is nothing but all these are representing I plus j, sorry all these are giving you indirectly an idea that it is nothing but -1 whole raised to I plus j. So this is the same thing. So you can define a new thing which is known as cofactor. So for finding the cofactor, what you have to write? You have to just write the minor, okay, minor matrix 6, 5, 3 and 2. After that you see here the sign convention. You see the first element is positive, so plus. Now this element is negative, so put negative. This element should be multiplied with -1, so it is minus. This element should be multiplied with plus, so it is plus. So this is known as the cofactor. I hope this is clear to you. This is a cofactor. Now I will take the transpose of this guy. Transpose, you might have heard about this. So usually represented as the operator T. So this is the cofactor matrix. So I will take the cofactor transpose, then we will call it as the adjoint. So this is very, very important. So this matrix is cofactor. Let's say this is cofactor C or cofactor. So adjoint of the matrix, let's say this is our matrix A, is nothing but we have to take the transpose of cofactor. We will have the cofactor matrix and take the transpose. So I will give you the idea. So what about the cofactor? So we have the cofactor now 6 minus 5 minus 3 and 2. So cofactor is equal to 6 minus 5, then it was minus 3 and 2. Minus 3 and 2. Now I am going to transpose this. Transpose. So what I am going to get? I will get, if I transpose this, so cofactor, I will take the transpose, then what I am going to get? I will get the adjoint of the A. How to transpose it? You see here, this is the first column for the first row, row 1, and this is the second row. Okay, so first row I will write it as first column. So I will write like this. This is 6 and this is minus 5. Okay, so I am going to change this guy like this. Okay, next, this is minus 3 and 2. I will be writing like this. This is minus 3 and this is 2. This is the transpose. So this is known as the adjoint of A. So adjoint of A is nothing but the cofactor of A and take the transpose of it. Okay, that's it. And how to get the cofactor? You will assign the plus and minus sign to the minor matrix. So you have the minor matrix, this one, and for the minor matrix you will assign the plus and minus sign according to this convention. That's it. So this is how you can calculate the cofactor and the minor, okay, and the adjoint. Okay, now we will see one example for 3 by 3 matrix. So let us assume that we have a set of linear equation. Let's say we have an equation. So we will first consider the set of linear equation. So linear equation. So we will consider in general a 3 by 3 matrix. For example, A11 into x1 plus A12 into x2 plus A13 into x3 is equal to B1. Okay, this is an equation. So this is equation number 1. So A21 into x1 plus A22 into x2 plus A33 into x3 is equal to, not A33, A23 into x3 is equal to B2. Now A31 into x1 plus A32 into x2 plus A33 into x3 is equal to B3. You can see that all these A's are representing the coefficients and B is the right hand side of this equation. Okay, so I can represent this as a matrix. So x1, x2 and x3 can be represented like this. Okay, and I have this guy, and on the right side I have B1, B2 and B3. Okay, now this is A11, A12 and A13. This is A21, A22 and A23. If you multiply, you will get the same equation 1, 2 and 3. Okay, so then A31, A32, A33. So you have the matrix A and you have the matrix X. This is equal to, you have the matrix B. Okay, so the general equation is Ax is equal to B. This is how you can represent it as a matrix equation. Now let us consider an equation. So let us consider an example. Let's say x1 minus x2 plus 3 x3 is equal to 5. This is equation number 1. Okay, then 4x2 plus, sorry, not 4x2, 4x1 plus 2x2 minus x3 is equal to 0. Next equation is x1 plus 3x2 plus x3 is equal to 5. Okay, so this is what. So I told you, whenever we have two variables, it is showing the equation of a straight line, and whenever we have three variables, it is just showing the equation of the planes. Okay, that I will show you. I will show you the videos in the next lecture. Okay, now here we will focus on the methods to solve this. Okay, so there are three equations, so I can represent it as a matrix. So first is, you see the coefficient here, it is 1, then second coefficient is minus 1, you see here it's minus 1, and this is 3, then 4, 2 and minus 3. Okay, not minus 3, minus 1. Okay, minus 1, here the coefficient is minus 1. So, and this is 1, 3 and 1. Okay, so this is the matrix A here. Okay, now for this matrix I am going to first find the determinant, but you see it is different from a 2 by 2 matrix. So what how I will be finding, so before that I will be assigning some sign. I will have some sign matrix. So I have some sign matrix. I will make a sign matrix first, plus minus plus, because this is 3-dimensional matrix. Next this is plus, so it will be minus plus minus. This is minus, so this will be plus minus plus. Okay, you see this is the sign matrix. So we will see now. Now you see here, to find the determinant, we will first take this guy, this element. Sorry, I will use a different color. So I will take this guy, this is 1, this is the 1, so it is 1, you see here, this is 1, then 1 multiplied with, what is our sign? You see here the sign is positive, so I will use the same sign, positive. Okay, then I will find the determinant of the remaining part. What is the determinant of the remaining part? You see here, the remaining part means, according to this 1, if you remove this, it is in the first row, you remove the first row and first column. So what is remaining? You can see the remaining thing is 2 minus 1, 3 and 1. So that's it. So this is the determinant, not determinant, this is the first part of the determinant. Now plus. Okay, next, now plus, you see here the second, we will be taking this element, so it is minus 1, but you see here that according to the sign convention, there is one more thing here, this is the sign, so the sign is negative, so I will put a negative here, so negative of minus 1, negative of minus 1. Now I am going to remove this particular row and I will remove this particular column. So what is remaining? You have this 4 and 1 and you have remaining 1 minus 1 and 1. So I will be taking the determinant of 4 minus 1, 1 and 1. Okay, that's it. Next I have the third element, which is 3, so I will use a different color. You see here I have the third element, this is 3, so plus 3, but I use the sign, you see here it's positive, so I will use the positive. Okay, so I can put it as in the bracket. Okay, this is positive. Now I will find the determinant of since I am talking about our 3, I will find the determinant of, you see I will remove this row and I will remove this column. So what is remaining? I have something remaining here. That means 4, 2, 1 and 3. So this is, now you see here, this you know how to calculate. So this you know how to calculate, because you can cross multiply here minus this one. So 1 into, so this is the determinant. So determinant of A is represented like this. So determinant of A, this is the determinant of A is equal to, you see here, this is plus 1 multiplied with, you see here 2 into 1, that means 2, minus 3 into minus 1. So 3 into minus 1 is minus 3. So 2 minus minus 3 plus, you see here, this is minus of minus 1, that means plus 1, multiplied with 4 into 1, 4 into 1, that means 4, then minus 1 into minus 1. 1 into minus 1 is minus 1. Okay, so minus 1, then plus 3 multiplied with 4 into 3, it's 12, then minus 1 into 2 is 2. Okay, so this is the determinant. If you calculate this, you will get it as 40. So the determinant of A is 40 now. Okay, so this is the determinant of A. I hope this is clear to you. Now I will write, so this is the determinant. This is how you can calculate the determinant of A. Next, I will write the same example here with A matrix. You know, A minus 1 and 3, 4, 2, minus 1, 1, 3 and 1. Okay, so this is the A. Now we will find the minor matrix. Minor matrix. And minor matrix I can find like this. So if I take the first element, you see, okay, if I take this 1, I can remove this row and I can remove this column. So the minor matrix will be determinant of 2 minus 1, 3, 1. That's it. Next, the second part, I will take this one. So I will remove this column and I will remove this complete row. So what is remaining? It is nothing but 4 minus 1, 1 and 1, right? Next, I will extend this little bit. Next, I have this 3. So I will remove this row and I will remove this column. Sorry, I will remove this row and I will remove this column. So what is remaining? It is 4, 2, 1 and 3, determinant of this. Next, I have another thing which is 4. So I will remove this row and I will remove this row and I will remove this column. So what is remaining? If I remove this row and column, then what is remaining? Here it is minus 1, 3, 3 and 1, right? Next, I will take this guy. Okay, I will remove this row and I will remove this column. So what is remaining? You can see only this element, this element, this element and this element. So it is nothing but 1, 3, 1 and 1. Then I have another thing, this another element, minus 1. So I will remove this row and I will remove this column. Okay, then what is remaining? It is nothing but 1, minus 1, 1 and 3, right? Next, I am going to consider, okay, I will consider this guy. Okay, so you see here, I will consider this. So I will remove this column and I will remove this row. So what is remaining? Remaining is minus 1, 3, 2 and minus 1. Okay, next, I will use a different color. That's better. Okay, I will use this color. I will see, you see here, this is 3. So I will remove that particular row and column. So what is remaining? I will remove this row and I will remove this column. Then what is remaining? It is nothing but 1, 3, 4, minus 1. Okay, So it's better 1 3 4 minus 1. Okay, next the last is I am going to consider this one. So this is, so I will remove this row and I will remove this column. So what is remaining here, it is what is remaining is 1 minus 1 4 and 2. So this is known as the minor matrix. So I can find the minor matrix, I can calculate the minor matrix as, you see, the first one, it is 2 into 1 minus, that means 2 into 1 is 2 and 3 into minus 1 is minus 3. So 2 minus minus 3. So it is 2 plus 3, it is 5. Okay, you can, I will write the steps. 2 minus minus 3, that's it. Okay, which is equal to 5. Now this is 4 minus minus 1, which is also 5. Okay, so here also I will write it as 5 and this is 5. Now 4 3s are 12, 12 minus 2, it is 10. Now minus 1 minus 9, it is minus 10. So 1 minus 3, it is minus 2. Now 3 minus minus 1 is this 4. That means 3 plus 1. Now minus 1 into minus 1 is 1. 1 minus 6, it is minus 5. 1 into minus 1 is minus 1. Minus 1 minus 12 is minus 13. Right? Now 1 into 2, 2 minus 4 is minus 2. So this is the minor matrix. Okay, please calculate and check whether I have made any mistake, okay, by yourself. Okay, now this is the minor matrix. Now how to find the cofactor? So minor matrix I will write again. Minor matrix I will write, you see here 5 5 10, 5 5 and 10, then minus 10, minus 2 minus 4, minus 4. Now minus 5 minus 13 minus 12. So minus 5 minus 13 and minus 12. Okay, so this is the minor matrix. Now I will find the cofactor. So before cofactor I will give you the sign matrix. The sign matrix, the sign matrix plus minus plus. Then this is plus, so minus plus. So plus minus. This is minus plus. Okay, this is the sign matrix. So I am going to find the cofactor of A. So this is the minor matrix of A. This is the cofactor of A. How to find the cofactor of A? Just assign the signs. So I will first write the elements. 5 5 10, minus 10 minus 2 minus 4 minus 15, right? Minus 4, yeah, minus 15, not minus 4, it's plus 4, right? It's plus 4, sorry. So plus 4, yes, so it's plus 4 only. Then minus 13, this is minus 2. After that I will assign the sign convention. You see here this position is plus, this I will put minus, and this is plus, this is minus, this is plus, minus, this I will put minus, this is, sorry, plus, and then this is minus, and this is plus. So what is my cofactor? I can write my cofactor as, cofactor of A as, you see it's plus 5 minus 5 10. Then you see here this guy is minus of minus 10 is plus 10, then minus 2 minus 4. Okay, then this is minus 15, this is minus of minus is plus 13, and this is minus 12. Okay, minus 12. Now this is a cofactor of a. Now we will okay, I will rewrite this cofactor of a as, you see here, 5 minus 5, 10. 5 minus 5 and 10. Then 10 minus 2 minus 4. 10 minus 2 minus 4. Then minus 15, 13 minus 2. Minus 15, 13 minus 2. Now I will find the adjoint of a, which is nothing but the cofactor of a. I will take the transpose of this. That means I have the matrix 5 minus 5, 10. 10 minus 2 minus 4 minus 15, 13 minus 2. I will take the transpose. Okay, I will take the transpose. So it will be the adjoint of a. So adjoint of a, I will take this row, I will change into column. So 5 minus 5, 10. Then 10 minus 2, 13. Okay, sorry, not like that. Then I will take the second row, then I change into second column. 10 minus 2 minus 4. Then I will take the third row and I will write it as third column. So minus 15, 13 minus 2. Okay, so this is the adjoint of a. And what was the determinant of a? Determinant of a was we have already seen the determinant of a was 40, I think so, right? Yeah, this is determinant of a. Okay, so we have seen how to find the determinant, cofactor and adjoint. Okay, now we are going to define something which is known as inverse of a, inverse of matrix. So inverse of a, inverse of a is represented as a inverse, like this. So we have a matrix, so inverse of a is equal to the adjoint of a. You divide the adjoint of a into divided by the determinant of a. That's it. This is the inverse. Okay, now if you know the a inverse, then if you multiply the matrix, okay, then if you multiply a with a inverse, you will get the identity matrix. So this is very, very important. It is like if you know the number, for example, in the real number case, if you have a number 3 into 3 inverse is equal to 1. So instead of 1, we have here I, like this. So this is the analogy. So 3 into 3 inverse. For example, we have the matrix A inverse. Sorry, A. What was our A? I will write our A, 1 minus 1, 3. Then 4, 2 minus 1, 1, 3, 1. Okay. And what was our A inverse? It is adjoint of A by the determinant of A, which is equal to, what was the determinant of A? It was 40. So 1 by 40 multiplied with, what was our adjoint of A? I will write it. 5, 10, this is our adjoint. 5, 10 minus 15. So it is 5, 10 minus 15. Then it's 5, 10 minus 15, 5, okay, 5, 10 minus 15, then 10 minus 2 minus 4, like this. So it is 5, 10 minus 15 minus 5 minus 2, 13. Minus 5 minus 2, 13. Okay, so minus 5 minus 2, 13. Then it was like 10 minus 4, 10 minus 4 minus 2. I think I have made some mistake here. Let me check the last number. The last number actually, let me check here. Okay, yes, I have made a mistake here. Please, you see here, this is 1 into 2 is 2. 2 minus 4 is it is 6 basically. This is 6. So this is 6. So this is 6. So this is 6. Sorry for this. And this is 6. And this is 6. And here also it is 6. Okay, I have made a mistake here. So I have 10 minus 4 and 6. So I got this. Okay, this is my A inverse. Now let us multiply our A into A inverse. A into A inverse is equal to, A is 1 minus 1, 3, 4, 2 minus 1, 1, 3, 1. Then there is a common number, that means it's 1 by 40. So I can multiply here itself 1 by 40. Now I have this A inverse, other part of the A inverse, 5, 10 minus 15, then minus 5 minus 2, 13. Okay, and did I make any other mistakes? Let me check here. Let me check here. Okay, it's 4 into 3. Okay, not minus 5, I think. So I have minor matrix is 5, 5, 10. Okay, so let me check here. What is my A inverse? I think they have made a mistake in this element. Okay, this element, I will check it. So the cofactor transpose. So this element is coming from the cofactor. So cofactor is, we will see. Yes, this is minus 5. So yes, this is minus 5. What I have written here. Okay, sorry. So this is minus 5. This is minus 5. This is minus 5 here. So this is minus 5. I can remove this 1. I have written it as 15. It's minus 5. So it's minus 5. Okay. Now this is minus 5. Okay, so minus 5 here and also here. Okay, so this is 10 minus 4 and 6. Okay, so this is what the inverse. So 1 by 40 into this matrix. This is the adjoint. So into A. So this is the matrix A, and these together, this guy along with this is representing the adjoint, not adjoint, A inverse. Adjoint A by determinant A, it is A inverse. Now if you multiply this exactly, you will be get 1 0 0 0 1 0 0 0 1. That is the beauty. This is nothing but an identity matrix. If you multiply this, you can check it out. Okay, so we have studied many things today. We have seen what is the inverse of a matrix, what is the inverse of a matrix, and also we have seen what is adjoint, what is cofactor, what is determinant, etc. Okay, now we will see how to use this for solving the linear equations. Okay, now let us consider the linear equation. Let us consider the linear equation A11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1, a21 into x1 plus a22 into x2 plus a23 into x3 is equal to b2. Then a31 into x1 plus a32 into x2 plus a33 into x3 is equal to b3. So I have the matrix a11, a12, a13, a21, a22, a23, then a31, a32, a33, and we are multiplying it with x1, x2, x3. It is giving you b1, b2, and b3. Now this is the matrix A. There are some properties we have to see. Suppose if first property that we are going to see is that if determinant of A is equal to 0, it means that the equations has infinite number of solutions, or it can be, or it has no solutions, no solution. So these are the two cases. If it has infinite number of solution, we will say it is consistent also. And it is consistent. In this case, no solution means not consistent. Okay. So if there is a solution, even whether it is one solution or two solution, it is consistent. But the problem is that if the determinant is equal to 0, then the equations are dependent, or we can say that the equations are dependent, and basically infinite number of solution or no solution will be the resultant. Now now we will see what is the situation if determinant of A is not equal to 0. Okay. So what is the reason? Okay, before that I will clarify the first point. You know that A inverse is nothing but adjoint of A divided by determinant of A. Okay. So if the determinant of A is equal to 0, then A inverse become, actually it will be infinity. That means you have infinite number of solution, and it's not possible to solve it correctly. Okay. So next we will see the second case. What will be if A is not equal to 0? If the determinant of A is not equal to 0, that means that A inverse exists. It means that A inverse exists. But in the previous case, A inverse does not exist. But here A inverse exists. So the solutions are unique. That means, unique means these equations are independent, or we can say that the equations are independent. That is the beauty. Okay. And the solutions are consistent. Also, one more thing we can say, the solutions are consistent. That's it. Okay. So consistent means there is a solution, and inconsistent means there is no solution. Okay. But even though if we have infinite number of solutions, we will say it is consistent. But the solutions infinite number of, there will be infinite number of solutions. So that is the beauty. So by seeing this coefficient matrix A, we can judge on many things. That means whether the solution exists for this problem or does not exist for this problem. Now let us consider how we can solve this. So we have now the equation Ax is equal to B. Okay. Now we have Ax is equal to B. Now we will multiply both sides, that means right and left sides, with A inverse. And you know that If you multiply with A inverse, A into A inverse is always I. We know this result. I told you. It is like, for example, you have a number 3 into 3 inverse is 1, like this, same like this. Okay, now you will multiply with A inverse. So first of all, I will write the equation. You have AX is equal to B. Now you will multiply here with A inverse. So you will multiply here with A inverse. I will use this equality sign here. Now you know that A into A inverse is I, and this is X is equal to A inverse into B. But you know that if you are multiplying any matrix with the identity matrix, you will get the same thing. So this is I into X. For example, if you have a number 3, you multiply with 1, you will get 3, right? Same number. Like this, if you are multiplying I with X, then you will get X. So X is equal to A inverse into B. So you got the solution. You want to find x1, x2, x3. Okay, that's it. So you will find A inverse and multiply with B. That's the solution. So this is the solution. But you know that A inverse is equal to adjoint of A by determinant of A. But if determinant of A equal to 0, that means that no solution or no unique solution. Basically, that's what we have seen. So you cannot find the A inverse in this case. But if provided that you can find the solution only if the determinant of A not equal to 0, then the solution is unique. Okay, and in this case no solution, and here there is solution. Okay, that's it. So this is how you can find you can solve this equation. So in the next class we will see more details on this. Okay, thank you.